So back to the structures of ionic solids. Ionic solids typically have crystalline structures that are very closely related to the unit cells that we looked at, but in an ionic compound we have two different kinds of particles. We've got the cation and the anion, so we don't just have one type of ball. Now we've got like oranges and limes or something, and we're trying to put these things together. And then we also have the restriction that we have to have a particular ratio of cations to anions. So here when we talk about the coordination number, a higher coordination number represents more close cation-anion interactions, which means a lower potential energy. But the crystal structure is going to balance the coordination number, the charge neutrality, and different ion sizes. And so we're going to blow through this pretty quickly. When we have ionic solids where the ions are of similar size, then things are relatively simple. This one is going to take a simple cubic cell. Here we're defining this as simple cubic based on one of the ions. It looks a lot like a body-centered, right? But when we identify the unit cell, we have to think of just one of the ions. So with relatively similar sized cations and anions, it'll take on that arrangement. If we're looking at something where the cation is much smaller than the anion, something like sodium chloride, if we weren't worried about charges, we could actually pack a lot more sodium ions in here because they would just fit into the spaces around the chlorine atoms. But we can't do that because we have to have equal numbers. And so this is going to occupy a face-centered cubic structure. And what we're looking at here is this is one of the faces, and there's that one in the middle. This is called the rock salt structure. And each unit here has 4 cations and 4 anions. And this is the sort of question I have seen on the ACS exam, where they'll give you a drawing like this and they'll ask you how many of each kind of ion are in this unit cell. When we have different sizes, then things get a little more complicated. Our coordination number is going to drop. This is known as the zinc blend structure. And here what we have is this smaller ion is fitting in the tetrahedral hole formed by 4 of the other ion. And so in this face-centered cubic, we have 4 tetrahedral holes, and each of them has a zinc ion. Then if you have a ratio that's other than 1:1, then things get even more interesting. This is called the fluorite structure. It's a face-centered cubic, and now there are 8 tetrahedral holes in here, and each of them has a fluoride ion. So that's a 1:2 cation to anion ratio. The anti-fluorite would be if you had 2 cations to 1 anion. I'm going to skip that.